Hi, my name is Bill Mattis, VP of Sales at CE+T Energy Solutions. And today we're going to discuss some newer technologies for residential and commercial microgrids utilizing modular bidirectional power converters. For those of you not familiar with CE+T, we're a global company based in Belgium, and we're named one of the best managed companies in 2018. In 2016, many of you may have heard of the announcement about us winning the Google Little Box Challenge. This challenge was a worldwide competition consisting of companies, universities, as well as individuals. And out of an extensive amount of testing, we were named the winner with the smallest working inverter. The unit you see on your screen, it fits in the palm of your hand and delivers 2 kilowatts of power. So what we're going to mainly focus on today is the grid and microgrids and how those can work together and what we can do to improve the resiliency of the grid, to our homes as well as our commercial and industrial facilities. So many of you have probably seen this slide before. It's the grid of the past, and it utilizes centralized unidirectional power generation, feeding our homes and businesses from central sources of power such as coal-fired, fossil fuel facilities, as well as nuclear facilities. So there's a number of problems that we've had with the grid, and when the utilities designed the grid many decades ago, there were a number of assumptions made about loads, storm surge, and other factors. These estimates, unfortunately, no longer apply. We're seeing increased demand due to our dependence on data as well as EV charging. We've seen deferred maintenance, and due to some weather calamities due to climate change, we're seeing a real impact on the grid, whether it's due to forest fires or hurricanes. Cyber attacks are also causing issues, and so developing a more resilient power grid is in everybody's best interest. Renewables are also adding some power quality issues to the grid, and so there are some technologies that can help smooth that out and make the grid more resilient and give higher quality of power to both residences and commercial applications. The number of power outages is also on the rise. In the US, even though it's known as having a pretty resilient power grid, is experiencing more outages and for longer periods of time. Companies and individuals are becoming more dependent on electricity, and we need to find ways to add resiliency to the grid and provide more secure power, especially during times of crisis. So this slide is giving you a little bit different view. This is the grid of the future versus the grid of the past. And this is dependent upon distributed power generation and bidirectionality. So you see a few different things in this slide that you didn't see in the other. One of the ones I want to really point out is the EV charging. You're hearing more and more auto manufacturers talk about coming out with EV vehicles only, and that is going to put an extreme strain on the utility grid. So we have to find ways to overcome that and allow us to have a greener environment and at the same time have a more resilient power grid. So there are two sides to the equation. What does the grid want from buildings? They want to see reduced peak demand, a more level load, which would make it easier for them to distribute power. They're also looking for help reducing operating costs and keeping the time of use evened out more, more equal throughout the day. They're also looking for a rapid short-term response to managing renewables. Renewables are really causing some impact on the grid, which is difficult to manage. So any help that can be given by the buildings and thus the end users would be a big help to the utility. Also looking for ways to stabilize the grid in an emergency and prioritizing loads and basing it on critical versus non-critical loads. And any third-party investment is also welcome. And what are the buildings looking for from the grid? They're looking for an incentive for responding and adding this flexibility, lower electric rates, and a choice of products that fit their desires. You see many companies now advertising they will be reliant on 100% renewable energy in the next 5 to 10 years. That is, that's a great goal, but it does place a number of challenges on the grid and how we're going to integrate these microgrids with the existing grid. And of course, reliability and resiliency are keys. As we become more reliant on data, we need to make sure that that information flow is sustained. As 5G becomes more prevalent and autonomous vehicles, we're going to need to make sure that the grid is up and running at all times. And finally, power quality. Voltage sags and harmonics are causing problems with various types of equipment. So if we can even all that out and give a better quality of power, everybody wins. So this mutual benefit between both parties can be attained, and I'm going to discuss some technologies that can help achieve that. So when you tie microgrids into the utilities, that's one thing, but then also adding resiliency, this is not easy to do. So one of the methods or one of the products that we would like to offer to the market is the stability. This is a 30 kilowatt inverter. It's modular and can be expanded, and it offers a number of benefits due to its 3-port single box design. By tying in PV and batteries to the grid, you have a number of benefits from demand management to peak shaving and giving you a more resilient power supply that is also safe for equipment and getting rid of a number of the variances that you currently see. This software-defined behavior allows us to work in a number of different modes and can be controlled through a power management system. This seamless shift can be adjusted based on real-time resources and loads to allow for changes throughout the day. Here's another example of a stability installation utilizing 4 of the stability inverters. There are 2 different options available, a 2-port AC and DC option, as well as a 3-port. The 2-port option allows for peak shaving and demand management, while the 3-port also has additional benefits for off-grid operation, utilizing solar and batteries at the same time, and integrating those all into the same box. That single box design offers a number of advantages over 2-box designs in the market, and just makes it much more simple to work with when you're integrating those with power management systems. It has a very wide DC voltage range from 100 to 1,000 volts, but it is optimized at 500 to 1,000 volts to get full power. You can operate the batteries and PV array at different voltages and sum those power supplies when you're feeding back to the grid. You can set that for a certain amount of PV that's available and add the battery storage on top of that to give you a certain amount of power delivered to the grid at all times. Another product that we'd like to propose is the Sierra module. This building block allows you to be extremely creative in your designs, and we have a number of partners that are utilizing this technology in applications from UPS backup to microgrids to portable electronics and power for power generation as well as vehicles. This multi-directional power converter consists of 3 ports. It has 2 AC ports and a DC port with a centralized DC buffer. This design allows for us to move power around through all 3 of the ports bidirectionally, and at the same time giving you 0 millisecond transfer time. This AC to AC connection gives you full double conversion and allows you to feed the load as well as charging battery at the same time with the same module. We can also take energy from the load and feed that back to the battery as well as to the grid in a regenerative braking application such as elevators. We also can use fuel cells and other types of battery chemistries for backing up the AC loads and feeding back to the grid. We are currently in the process of getting UL 1741 SA certification, and once that is completed, we will make an announcement, and so please keep an eye out on our LinkedIn site so you can get more information of when that feature is available. So traditionally, your loads are seeing all the dirty power that comes from the utility. As we mentioned earlier, voltage sags and harmonics are difficult for some power supplies to deal with. So by utilizing the Sierra module, you can get full double conversion, which would first give you filtered power and protecting your loads from those disturbances. Secondarily, by connecting it to a battery, you also get the availability of backup power to keep those loads operating during an outage. Due to the bidirectional nature of the module, it also allows for peak shaving and demand management, which can be very useful in cost savings for both residents and commercial applications. By utilizing a 2-port version of the Sierra module, which is a DC to DC converter, we can also connect renewables and convert from 380 to 48 volt DC, allowing for residents to have a smaller battery on site, but utilizing that 380 volt solar array on the roof. This modular design allows for redundancy and scalability, which means you can, based on your current loads, you can size a system, say for 20 kilowatts, and if you have an anticipated growth in the future of, say 40 to 50 kilowatts, you can just buy a bigger chassis and add modules as needed. So you're only spending money for the power you need at that given time. You don't have to rip and replace like other types of systems. And because it's modular, utilizing approximately 2.5 kilowatt modules, you can, if you do have a module failure, usually you'll have a redundant module which will keep your loads up and running, and at the same time have a very small amount of power lost during a module failure. These are also hot swappable modules and can be replaced by anyone. There is no special tools or trained technicians required to change out modules. So it works very well in remote applications where it's difficult to get technicians out on a call. We take those modules and we build them into systems as you see depicted here. This is a 100 kilowatt cabinet with battery backup, and it is fully scalable. We can also put additional cabinets together in parallel to increase the power in excess of a megawatt. There are a number of different voltage opportunities available, from single phase 120 to split phase 120 240, as you'd see in most residences, and then getting into the commercial and industrial arena with 120 208 3-phase, as well as 277 480 3-phase for your industrial applications. We have 2 different DC voltages available, both 48 and 380, with 125 volt DC coming in the near future. These systems are scalable and can handle dynamic allocation of the AC and DC loads, as well as battery charging. So as your facilities may change from being maybe primarily AC loads today to maybe majority of DC loads in the future, this system has the flexibility to make that change over time. Due to the modular design of the system, you get full redundancy so that you can keep your system up and running for mission critical applications. And it can be operate as a 0 millisecond transfer UPS, so your loads would not see any glitch. We're utilizing this type of equipment in all these types of applications, from residential, especially high-end entertainment applications, to industrial applications where we're backing up CNC equipment, as well as tying in with a microgrid on site. We can also connect through a power management system through the cloud and be able to turn existing sites' energy storage systems into virtual power plants. The system is battery agnostic. We work with many different chemistries, so you can utilize the type of battery that best fits your application based on cycling requirements, backup time, and the types of loads that you're operating. So I want to thank you today for joining us to learn more about our multi-directional power converters. And we look forward to working with you in the future on your projects for both residential and commercial applications.